So in this video, we'll talk about intersections of lines. Intersection of two lines. Great. Like always, let us have our coordinate system, like so, and a one perpendicular to that being our x-axis, like so. And let us have two lines. Let me choose another color. First one be, okay, this, and the second one be this. Cool. So this is the line L2. I'll represent this by line L1. As always, this is our x-axis and this our y-axis. Now, if the equation of line L2 is y equals m2x plus c2, that is the slope of the line is m sub 2, and this distance right here is c2, then this is the equation of the line. And similarly for L1, let us have the equation to be y equals m1x plus c1. That is to say that the y-intercept is c1 and the slope of the line is m sub 1 or m1, whenever it's more convenient. We now want to figure out what are the coordinates of this point. The key points, the key information in terms of finding the intersection point for two lines is the fact that the point at which the two lines intersect, let us call that point by x sub 0, y sub 0. This point is actually satisfied by the two equations. The other way to think about this point is present in both the equations. So as we have seen before, that if we have a point that does not lie on one of the lines, it will not satisfy either of the two equations. Say if we choose a point to be here, say a comma b, then we know that b won't be equal to m2a plus c2 because it does not lie on the line L2. And if we choose this point here, say which lies on the line L1, say with the coordinate c comma d, then we know that d will be equal to m1 times c plus c sub 1. This is how c and d are related because it lies on L2. But remember, d will not be equal to m2 c plus c2 because it does not lie on the line L2, and this is the equation of line L2. So those things in mind, there is a special point that satisfies both the equations. Let me just get rid of the equation just to declutter the screen, like so. So we are in the hunt of this point that is supposedly satisfied by both the equations of line x sub 0, y sub 0. Now, if this is satisfied by line L2, then y sub 0 must be equal to m sub 2 x sub 0 plus c2. So it satisfies line L2. Similarly, if this point lies on the line L sub 1, then y0 should also be equal to m1 times x0 plus c1, that's c2. So this means that the line satisfies L sub 1. So with that equation, with these two equations in mind, we can choose to solve them and by using the simultaneous properties, or that's really a fancy way of saying that we need to solve for y sub 0 and x sub 0. We have two equations and two unknowns, they being x sub 0 and y sub 0. The others are just constants, m2, m1, c2, c1. These constants are known to us if we know the equation of the line. So the only job that remains at this point is to solve for both of them. So let us try to solve for, say, x sub 0. So if we want to solve for x sub 0, we must eliminate the variable y0 or y sub 0. What we can do is we can subtract the equations. So if this is equation 1 and this is equation 2, we can do equation 1 minus equation 2 to get y0 minus y0 equals m2 minus m1 times x sub 0 plus c2 minus c1. So we have that, no matter what the value of y sub 0 be, the LHS is always 0, we can then simplify for x sub 0 as x sub 0 turns out to be, shifting this term to the LHS, we get C2 minus C1 by M2 minus M1 with a negative sign. So this is the location of the x-coordinate of the point. Now that we have solved for x0, we can solve for y sub 0. And all we need to do is substitute this value in either of the two equations. So substituting x sub 0 in, say, equation 1, we get y sub 0 equals m2, and substituting x sub 0, we get minus c2 minus c1 upon m2 minus m1 within brackets plus c sub 2. We can choose to simplify this a bit more to get m2 minus m1. Multiplying this internally, we get minus m sub 2 c sub 2. Then this negative multiplied with this negative gives you a positive. Hence, m sub 2 times c sub 1. Now we multiply this denominator to c2, and we add them because we have taken a common denominator of m2 minus m1. We get c2 times m2 minus c2 times m1. It's easy to see that c2 m2 cancels out, and you're left with y sub 0 equals m1. This should be m2. m2, because we multiplied m2 to c1, m2 times c1 minus c2 times m1 equals m sub 2 minus m sub 1. So that is how we would choose to solve and simplify the equation and obtain values for x sub 0 and y sub 0. So if we are given the equation of the line, that is, if we are given m sub 2, c sub 2, this and this, so we are given these four values, we know that the intersection point would be of the form this, and the x-coordinate of the point would be this, and the y-coordinate would be that.